today's going to be a fun day. I have got a nice wide open block of time. So I'll get an hour or two now before lunch and then a few more hours after lunch. We should be able to get a lot done. Since I remembered today, I'm going to remind everyone that everything I'm working on is funded through Mr. Forth Lab. You can go to mrforth.com to see all kinds of stuff. On the mrforth.com/membership page, you can help to fund it and check out some cool perks you get. But, do this if you think that what I'm doing is cool and you want to help me keep it going and you've got the spare money. I know not everyone's got spare income, but if you're one of those people who thinks what I'm doing is cool and you do have spare income, take a look at that. You can also come over here to the main page and get on my newsletter, and you can look at some of the code I've already put out that is open and things I've written about and so on and so on. So, oops, this one is a little different. I'm just going to change it. So anyways, that's just a reminder about the Mr. Forth Lab. Now, let's get to this RPG simulator programming. Yesterday, I spent a few hours sketching out a brand new system and kind of started chipping away at it. And I left the code in an absolute disaster. Since today I've got kind of an unbounded, I have a feeling inside me and just in my schedule to the vibe of today is that nothing's going to stop me from getting this thing working. So the question is, how do I want to go about it? One way I can do this is I could just start running it, and whenever there's a crash, fix that, move forward from the front, like the frontier of how well the simulation is working, how well the program is working, and get that all, progress from that wavefront. The other thing I could do is use the compiler here. I could unzero out a bunch of this code over here that's currently inside of an if0 block and start trying to get it to build. There are also all these issues here that I know I'm not going to find in the compiler. These are the kinds of things that I'm going to find in the runtime of, I used to depend on being able to get this combat context in different ways that doesn't exist anymore exactly. That's part of the system isn't even built yet. There's also all this dead code that at some point I should clean out. So there's a couple different fronts that I could use to make progress. I'm feeling like let's start with the crash, and the reason for that is, well, okay, I do want to track down one thing. I have a question for myself, which is, I know yesterday I started touching this registry thing. Did I ever get to the point where I know how I'm going to register these rules? I know how to register the U32, so this definitely all needs a cleanup at some point. The registry system is super under-equipped for what it's carrying now. And the names of things are weird, and the parameterizations of things are weird, and the bundling of things is all weird. It's all weird. All of it is weird. But that part looks good. Kind, proto, num, the list. And we stick some memory down and link it in. So that's all fine and cool. The next question is, did I actually get to use it anywhere? And the answer is no. Okay. So I think the right place to start is I need to at least be able to define the rule script macro. If I don't have that, then I don't even have the core concept of the system up and running yet. And so I want to be able to build that data structure of of mappings between rule patterns and the actual hooks that implement some of the rule patterns. And then once that basic structure is in place, we can try and figure out why we're crashing and fix that, and then start trying to get these all to work. But I think that's the right order of steps. the rule script will take in a number and a list of arguments. Okay. I want to stop and think about this for a second. Because I remember since yesterday, a thought has occurred to me about how this counter thing, it might not work. And I just want to think this through out loud now that I'm looking at code. So the big concern is that the counter, the whole point of using the counter here is to generate symbol names automatically that will not collide with each other, right? I can't just say that the name of this is going to be RPG rule script by itself because I need more than one of these, and C won't let me have two functions with the same name because then it won't know how to link anything together. So I have to give them all different names, but I don't actually care what their names are. I'm binding them to this data structure of rule patterns, which are these like orders of like these sets of multi-sets of states or something like that, a collection of states. And that's how I find the function that I need, is with a runtime data structure, not with a static name. Now the question is, how do I set it up to avoid the extra step of having to be like, okay, because what I could do is just go like, this is going to be called combat start, and this could be called combat chasing it, right? I could just go and put in a stupid fucking name for every one of these. Right? It's possible. But it's annoying, and so I'm trying to avoid that. And I thought the way I could do that is by generating the symbols, because I can't skip them, C needs them, but I could generate them with this counter macro, because the counter has a different value every time you use it. So as long as I only use it once to generate the name here, then when I pass that down to the next layer, it'll use the same symbol for several spots, binding everything together the way it's supposed to, and having a unique name, right? Except except that the counter starts at 0 for each compilation unit. So if there are going to be multiple compilation units, this might go out the window. Now, these are all statically linked functions right now, and that means maybe things are fine for now, but will that always be true? Here's where that could stop being true. Right now, I connect this function pointer to I bind it into the runtime data structure by having this registration system, right? I do a registration here, and that means that at init time, before my main function runs, all of these things get set up in a data structure that I can then process and turn into the actual map that I need later. And so I don't need I don't need the name to be wait, how is this supposed to work? Right, so this is a little off, but this would be like var u32. You need a symbol name for the register as well, and then you throw down your proto kind, or reg data kind is going to be reg data kind is going to be rule, and then you'll sit this right here, That's the actual function pointer. I was looking at this thing like, wait, how does the function pointer get into this? But it's because this isn't real. So what happens now that it's a little more real, this is what it looks like. So the thing happening here is this. This is static. At init time, a function pointer is passed here. So we have a pointer to it bound into the data. And what am I trying to get at? The issue is at some point I might not want to do all of this through before main function. So I'm doing it with a before main function now. But if it gets to the point where there's a lot of those, there is a little bit of like processing cost to running them to build the baked data structure. Ideally, the baked data structure could just be baked ahead of time and then built into the executable, right? And I don't know how a workflow like that would look. That might need a pretty deep reimagining of what is and isn't allowed and where the boundaries are drawn. I might need to program that through a specific kind of programming that I don't have yet. But if I were to set that up, what would change is that this would now become a problem, right? The staticness of this function would become a problem, because how would you build a data structure that you can build into an exe that has a function pointer in it when that function pointer is actually well, okay, so the main thing I'm trying to figure out here is if there's no symbol for it, if it's statically resolved, then there doesn't have to be a symbol for it in the object file. Which means that what is in the object file here when this gets called is this gets expanded here as a function pointer. And so that pointer has to mean something. So a piece of executable code here contains within it some kind of relative addressing to this function, right? It's going to use some kind of RIP relative addressing to reference the function that I'm thinking of, I think. Or rather, to build that address. It'll take the current RIP and it'll do some offset from that. And so when it builds the final data structure, it'll have a function pointer, but it won't have a symbol name to go with that function pointer. And in order to give it a symbol, and the problem with that is then when you go to bake it into a different data structure, the new data structure you bake it into would usually need to be the sort of thing that would have relocations to symbol names. That would be the easy way to do it, through object file manipulation. If you can't do it that way, I don't know how you would reconstruct it. I think that ultimately you would lose the ability to actually... My vision of being able to bake it ahead of time might not work if I have to do it with a static function. I don't know. So I think this is going to have to be a flaw that I accept for now. So I'm going to keep this thing where I don't put names in. And that might just be a flaw that I have to accept. It is the ideal thing, and I'd like to shoot for the ideal thing, but I also just don't know how details shake out when I want to bake these scripts. I haven't refined the C scripting concept yet to that point. So I don't know. And I can foresee an issue, and I either have to compromise on the quality that's available now, in order to leave open possibilities, or I just have to accept that later I might find out that symbol names are necessary, and that I'll have to, like, manually specified symbol names are still necessary, and I'll have to go through all of these and throw names on them at that point. But I think I'm just going to accept that this is a potential problem for now. Okay, so the counter part, I've thought that through. I'm satisfied with that answer. It might come up later and it might suck, but I don't want to change what I'm doing since I don't actually know exactly how the future of that is going to look anyways. This can pretty much look like that now. No, it's not Emacs. This is a text editor called 4Coder that I made years and years ago, but it is entirely inspired by Emacs. So it's meant to look kind of similar. Yep, I made it. I mean, I did most of it. The ports, I got help from other programmers, and the community maintaining 4Coder now has taken it a lot farther than I took it. I haven't touched it in, I don't know, 5 years, 6 years. When's the last? I think it's been about 5 years since I touched it last. But other people have been maintaining an open source version of it since then. All right, now we gotta debug macros. This is gonna be my favorite part. What are we saying is going wrong here? It's obviously the rule script macro. Let's just try decomposing this one step at a time. So this goes here. Wait. Keep the original. And now try to decompose it. This goes here. The 2 goes there. And what do we get? Still no good. Same problem. All right, let's try this. So declare hook 0. This will go here. And then this one is the one that goes here, and that's hook 0. So if this works, that pretty much indicates that the glue counter isn't working. But if it, okay, so that worked. Right, that doesn't work because it's not a macro. Like, you can't use pasting outside of the preprocessor. But this works. So I'm gonna guess that the main problem, I have a guess. I think that the problem is that this isn't enough layers here. This is the usual nonsense regarding macros, right? So you gotta, if it doesn't apply things when you think it should, you just add another layer and see if that fixes it. So this is simple num varars, right? There, okay. Damn. That kind of blows, but there we go. Okay, so that gets us that far. Now we're just unveiling all these things we don't have yet. So this is clearly not going to work. I think I just need to delete the old moves system, actually, which could lead to a lot more breakage. We got that. Okay, so these are still coming up first. Did anything else break though? Okay, cool. No. So it didn't break too much. Most of it's all under if 0 at this point, so there's not so much that can break. Now, context didn't actually end up grabbing that P. I think I will make that move, though. Okay, player. If this is real, if this is actually where I'm gonna go with this, then I need to take a minute and add this to the sketch. I never sketched this part. Or rather, I never drew it. I sketched it in the code, you know. So some day 3 ideas here. Thoughts about players. So point number 1 is that the rules contain that's just that thing. I saw this little fleck on the side and I thought it was okay, that was actually pretty good. I'm gonna just do it one more time because I didn't actually do it intentionally. It just turned out nice. So, what are the things I want to write down about players? First of all, Okay, so I'm gonna just write down some points here. The machine contains a set of players I think that's good enough penmanship. That works. Decisions are points in the instructions of the rules which work like functions that take a player parameter so a decision, actually that's the wrong color, a decision x to y is just a function that takes a player and x and returns a y. The player decides y given info x. Right? A player can stand for a simple NPC bot brain or a real human player with a visual interface or any other type of player or a what do I want to say, a player stand in AI in quotes not buzzword. Okay, just gotta make sure that's clear. Okay. Yes. Each party in the machine's state array should map to a player. So we go and look at what we were talking about how to annotate the state array. The state array has this n. So we want something like p count, the integer set starting at 0 for p count maps to a player, right? And the reason I'm doing it that way is because, yes, I want to say that the party maps to the player, but I might have such a thing as a party that's kind of on ice. It's not being played. It's in a different data structure to get plucked out and put into the game later. And so, simple characters that aren't going to play out anything more complex will just be on an NPC bot brain, and that NPC bot brain can essentially expand to run any combination of parties that are at that level. Now, I don't even know if I was gonna make a game out of this, if I would ever want to use the multiplayer possibility to include like AI players that are at a higher level than NPC bot brains, or if I'd be trying to make like a multiplayer game for actual like multiple human players. Those are all things that I think should be possible to model with the simulation language, but I don't think that I actually intend to necessarily think about going that far. But since I want to be able to model them, I want to be able to at least say things like, well, what if I have some like slightly more sophisticated player logic than just the basic NPC logic in order to run something like a rival party, right? You could imagine it's not necessary to put like a whole machine learning algorithm in there, but you might want to like script up a rival party kind of concept into your RPG, and that rival party might need brains that are a little more sophisticated than an NPC brain in order to issue some, or in order to deliver some more sophisticated tactics, right? And it might also be interesting to be able to pit that brain against NPCs for some reason. Like it just might be like, I don't know. I mean, imagine, for instance, that you have a move that will allow you to force your rival to deal with an NPC encounter before they deal with you, because it's a part of the way the story flows. It's a trade-off, and you can hit them with this thing if you set it up right, and then whatever damage that does will be based on the simulation of actually letting them play it out, right? Point is, I can't say that every party will always have a player, because something like the rival party might not be in play, and so that player might not be active and might not be present. But I might want this sort of idea of putting parties in and out of play. But once a party is in play, each of those slots should contain a player. And then in order to map from the parties that are in play to the players for those parties, you would just have to like go from the party to the index, from the index to the player, right? I'll make a note about that. Okay, so some more thoughts about the players concept in particular. There's still something lingering here. So I've talked about how there are players that I want to be able to write sort of language that's like decide this, give it a player, and give it some information, and have a decision come back. There will be multiple of these or different types of decisions, but this could be something like decide. Here, for instance, is something like decide out of a fixed set of decisions, whereas here we're saying decide based on a set of moves that are available and a set of limitations on how many of them you can use. And whatever the case is in terms of what kind of decision it is, it basically comes down to you have an idea for a type of decision, and there's some information trading. There's some exchange of information happening. So from one perspective, this is like there's the game rules. Oops, I'm in the wrong color for this. Zoom in. Here's a picture of what's going on. View of decisions from outside. The outside. I don't know what the player local language looks like. Which is kind of interesting. I think that's part of the next thing I need to build out. Hey Gabe, welcome. So this is the view from outside. This language will see send a decision to this player and with this X information, and then read back the Y value from whatever the player's choice there. This sees either it could be a bot brain, in which case it just I mean what this yeah, I guess this sees different things depending on what kind of player it is. From a bot perspective, this is just a function that implements decision XY. From a human player perspective, this is a separate coroutine that has a live UI loop in it, right? So this over here is the game logic timeline, and this over here is a UI timeline. And time here is not advancing when a player is supposed to decide something, and this is sitting here looping, and when a decision finally gets made, it submits a Y, and time here goes again, right? So if it's a human player, this would look something like for a human interface, this would see something like loop x equals get state UI equals build UI. So that's kind of what a human interface is going to look like in terms of code. And then if this is a bot brain or an AI brain of any kind, then this looks like this, right? Okay. Okay, so something else I want to be able to talk about, though I'm not done with players, is what actually is the information. X is kind of a little bit oversimplified. This is a part I'm not clear about how this wants to work. Um, Okay. I think that's everything I have to say about players for now. Um, yeah. Okay. I don't actually know what to put in the player yet. I'm kind of wondering if I want to change my mind already. I thought this would be a good way to do it, but I just want to explore the possibility of saying that I assign it to an entity outright. If each entity has a player pointer, or can have a player pointer, then the next step from there is to say, like, okay, given an entity, you should be able to ask what party or what player controls that entity. You can do that for characters. We're going to eliminate tile entities eventually. Characters all belong to parties, so we can look up the hierarchy to find that. We're still using lists. Not right now, so we might end up eliminating lists. And I don't know, doing this might actually solve some other problems. So the next step after having a good system like this would be to ask, how is something like mind control gonna work, right? If I want to simulate the idea that I'm gonna reach into the perspective of a different character and make their move for them for as long as that's going on, how would I expect the whole thing to work? How would I expect to organize the process of assigning move space to each player in such a way that kind of a story, that kind of a ability could play out? Um, and And the cool thing about putting it right on the entity, putting the player right on the entity, is now the way the story would work could be something like when a party entity has a player, that becomes the default for each character in the party. But if any of the characters set something other than null for their player, then that's like an override. That character is now actually being controlled by a different player. And then figuring out what you can see and what you can decide would be about collecting, for one player, it'd be about collecting all of the things that that player can control in terms of moves. And moves happen through the characters, not through the parties necessarily. The parties will stay together. So in order to, like fully control a character, you would want them in your party so they can stay with you. But if you're temporarily controlling them, with a limited amount of magic or other mind control kind of implication, then yeah, I think that this makes sense. All right, this is going to change a little bit of the picture. This note is still kind of true, but it no longer would have come up if I had been doing it this way. So maybe it's less of a critical issue than I thought. It's actually each character and each party, I think. Each party Okay, there we go. That's a little more like it. I'm gonna get up real quick to grab a snack and keep going. One sec. Ah, so this is getting used. Where is it getting used? Right, we don't have an operator for this that's not tied into the basic piece. um, Um, I want to revisit this. Pick one. Okay. So here I named these decisions before. So I think this might be like decision pick one. I give it a player and I give it X. In this case, X is the list of possible moves. We tell the player to pick one. And now so I would have to go like here. Context, player, count, moves. So there we go. For now, what it means to make a decision is to take the first one in this case. This obviously has to expand out to somehow multiplexing on all the different ways we might want to implement player. Not sure how that'll happen yet. Go to array. Oh, cool. That's good. All right, so what's next and how do I figure it out? We still run and crash, so maybe I can hack it from that angle for a little bit. But we're building the first rule here. So I'm also curious if we're running the rule at all. Now, another thing I have to do at some point is like I'm thinking I'm gonna just need RPG brain scripts. Something like this. I'm not sure what quite to call it. Um, okay, so we'll build a default brain. Brains, if they look like this, it'd be like combat round, and then and this would change other things about brain scripts, like this would suddenly look like RPG brain script tile. So this would extend the default brain, and this is the default way to protect. And how I want to go about parameterizing something like this will be interesting, right? Because here, I mean, here I'm saying I want to bind this script to this decision through the state. I could also use the string. Here, I'm saying I want to bind it through the tile name. I could also say, you know, in a tile script, it's more like this, right? You could go all the way down to just saying use this tile. And that's the only thing you're actually allowed to do from a tile script anyways, I imagine. Because this is a rule about how to think about whether or not to use this one thing, so that if you have just some basic characters you're throwing together, you can just have the default brain include things like, okay, use this ability always when possible, and this brain is up here saying like, okay, just always fight, unless you've been programmed to think in a slightly different way, whether it be to be cautious. You know, maybe there'll be like a wolf pack and enemy that runs away if the fight's not going their way, so they're harder to actually knock out if you don't get them all at once. And then you can imagine a thief party that steals something and runs away, and you can imagine a magical pixie character that you have to chase them and catch them to get something, and they are impossible to hit or whatever, right? There's all kinds of different reasons to override it, but the default brain sits there being like that, and then it would expand. It would be like, okay, this is thief brain. This is a little rough. This isn't quite right. Don't worry about this part too much. It would be something like this. Right? Yeah, we'll have to think about that more, but somewhere in there, something like that makes sense. There's some missing pieces, like how this gets set up and how long it lasts. How this composes with this so that other moves can use their defaults, while some use the thief brain overrides. And if there might want to be more like a mixin structure here where I can stick together a thief brain and a wizard brain all into one big party, and have the overrides overlap each other correctly or something. I'm not sure. Okay, in the meantime, I think I want to approach this through the crash now. Cool. Okay. So where that landed was, it doesn't find this because the rule scripts don't actually get processed into anything. Okay, yeah, so let's do this first. The old moves are out. Okay. Hmm. So, okay, I need to explain where I'm getting lost here. There's an issue, which is that these patterns need to be normalized in the sense that we think of them as being arrays, except that two of them are equivalent. They're the same pattern if you can shuffle one of them to match the other, right? This is permutation independent. We just care about the count of each value in the array, right? It's an array of states. If the count of each state is the same between two, then they match. And we're trying to normalize them so that everything that matches all normalizes to the same thing. That's easy. You just sort it, right? But the problem is, if we change the order of the states in the pattern from what was written by the programmer in the first place, the mapping from the slots of parties to the states is no longer statically known. And I kind of want to keep that property. So let me show you what I'm talking about a little more up close. This is a good example. It's an okay example. This is a good example. So this example, you can see we care about the order. The one that goes first makes some decisions, and then some moves get applied, and then the second one goes. So the decisions get made here on the first iteration affect the state of the system before the second decision gets made. So which one comes first matters. And I don't want to have to say like, okay, whatever you wrote here is irrelevant. They're in a different order. P0 should always be this one. P1 should always be this one. And that should match for any of these rule patterns that work this way. So so if we're gonna normalize it so that we can match them, we still need to be able to put the actual state array in the correct order for execution. And I'm not sure how I want to do that. There's a couple ways I could imagine doing it. One is I could normalize both and keep a permutation key around for each rule. So this rule here would keep a permutation key that would either look like 0, 1 or 1, 0. It would be the rule you would use to unshuffle them to take them from a sorted or normalized order to the local specific order. It would just be one extra linear pass through all of the state arrays, which there are two of, I should say. We're not going to have 3 because we just have P and S, right? So we would just have to swap some of these around, or if these arrays get longer, you would just permute them. Although I don't actually expect them to get much longer than 2, unless it becomes a different kind of pattern, right? Like if you get to the point where you have 10 parties, then you're probably not going to list out every combination of states that you expect all 10 parties to go through. We're going to have to learn how to decompose those states in even more rich patterns than just what I've got. We haven't gotten that far yet, so I'm not worried about it. I'm just learning how to walk today. The 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 idea of just keeping the permutation key is the easiest, most direct fix. I feel like there's got to be a way to reimagine this a little bit that I'm missing. Like, I don't know. I don't know. I mean, ultimately, I want to lay out the parameters of P and S in an order that matches the thing I wrote. And there's never going to be a guarantee that the thing that's originally put in by the system is going to be in the correct order. So, the absolute most direct thing I could think of is to store these things permuted in the hooked from there to there, but also store the original order or the unshuffle permutation, right? The permutation to map from the normalized order to the expressed order. Something like that's just always going to be a part of it. So the question isn't which one to do; it's which one's more convenient. The cool thing about this is well, yeah, I'm modifying the raw pattern directly. I guess I really do just need a permutation key to go with it. For now. Okay. I think I'm going to take a 5-minute break here. Let's see, I'm almost at 2 hours. Yeah, I'm going to take my 5-10 minute break here and come back and just pick this up from there. I'm going to equip this part. Here's where we're at. We need to set up the unshuffle key instead of saving a proto. We need something for a rule, and that'll be it. I will come back in 5 or 10 minutes. Let me grab the sign real quick. All right. I will be back shortly. should stop closing that sign when I get back. It's a bad habit. So a rule is going to consist of a hook, and an unshuffle. So one issue might be that that's also probably how I'm inserting things into the buckets right now. So I might actually be going back into the whole string bucket thing and thinking this through a little more carefully right now. Like, this might need to be something like a rule from pattern. Proto-kind init is the other possibility here. Proto-kind init. What were you doing? Right, you get your rules from a global variable, from global memory. So presumably here you set the name. Okay. Stick the pattern in like that, and the rule like that. And we cheat because we're hacking it and tell it that's a proto pointer when it's not. It's a rule pointer. That's all. The types are just being thrown out the window, and I need to go fix it. But the rule is basically a hook and that unshuffle. Right? That's what the rule contains. Set up the unshuffle key. There's the rule. Okay. Right, and this actually needs to get turned off because we're not ready to build that rule. Okay, let me go do one thing, then we'll implement that. Okay, so that should mean we're putting normalized pattern keys into the map, pointing to these rules, which then contain the executable hook and the unshuffle key. So that should all be good. The issue now is this. Rule from pattern. It's an unshuffle key, and it's when you sort. I guess I made the wrong name. It shouldn't be unshuffle. It should be unsort. That's a good catch. But that's only because of the fact that I'm actually doing a sort. So I don't know. I guess both names actually apply. You could apply the same exact concept to a shuffle. Basically, it's if you take an array that you're going to sort and you make it parallel to another array of integers that just index itself. So it's an array of integers that goes 0, 1, 2, 3, 4, 5, 6. And then when you do the sort, you apply the same swaps to both arrays together. While you're only using the first array, original array, for the sort, the second one tracks where each thing ends up. So that if you want to, you can undo what you did, right? You can lay the thing, you can get it back into the original order by, or you can get it back into the intended order by applying that permutation, right? Now I have to be careful because there's two different ways that this can apply. Like, which way it goes matters, and I guess I didn't stop and actually think about it carefully. But what is meant by it in this case is there's a certain order that these come in. So, let's say A, B, and C. And so 3 different states, 3 different parties, all in a different state. The states are A, B, and C. But they don't actually, that's not the correct sorting order. It's actually B, C, A is the correct sorting order for when it's normalized, let's say. Then what will happen is that my unsort, as I normalize the pattern, the unsort key will come out in the order 1, 2, 0, right? Because if we map ABC gets mapped to BCA, then 0, 1, 2 in parallel gets mapped to 1, 2, 0. So this is the unsort key, or the unshuffle key. And then if I have my state array looks like this, but I want to call this, then what I want to do is I want to rearrange things so that it's back in this order, A, B, C. And so what I'll have to do is I'll go, okay, scanning the unsort key here, I'm going to use that as a template to say, okay, whatever, this should be in slot 0, this should be in slot 1, and this should be in slot 2. And so I should be able to take BCA, the order of states, or the order of the parties that are in play, together with 1, 2, 0, and output A, B, C, right? That's the idea. So unsort is the kind of function where it takes in this key along with an array and gets it back into the original order if you build your unsort key this way. That's the idea. Okay, I think it's now time to figure out why I can't step into it. Although, okay, looks like part of the problem might be I just didn't actually finish the update to the rule here. You could save a list, but in this case, the point is more that it's like I have a list of parameters that looks like this, you know, S1, P1, S1, P2, S2. Let's do it this way. A, B, P3, or something like. Let's actually swap it. So I might have. Yeah, let's say I might have a state array that looks kind of like this, and then I have somewhere a rule that says if you have a B, an A, a B, and an A, or something like that, or you might say, you know, this might just be that they had a different idea about which order of relevance A and B came in, but you know, this is ordered according, when this is normalized, is ordered according to some arbitrary assignment of values to A and B, and when this gets written down, it's just some human intuition about, you know, what the first, second, and third parameters to a rule, like procedure to a hook are, right? And so you want to call this, I want to be able to call this rule with this state, but with the P3 going here and the P1 and P2 going here and here or here and here. It doesn't matter which way they come in. And so the rule comes with, as it underneath the hood, this comes with a hook and the unsort key to get from a normalized pattern to the original. And the way we figure it out is by normalizing this pattern. When we normalize this, we can store the rule into a map and also save the unsort key here for actually executing it later. So the array we're sorting and the array we're unsorting are actually different arrays, but they need to line up because they're like parameter argument pairs. And that's it. That's how you do that. You take in that and you go boom, 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 and then you just do, okay, that's cool. If unsort is a null pointer, just don't do anything. And the reason we might want that is that we might sometimes know that we don't need an unsort operation because they're all the same, or it was already in sorted order in the original pattern of the parameters. So the normalized pattern, just the unshuffle is unnecessary because it's already in the legal order. The one issue with that is I'm using quicksort, which isn't a stable sort, so it might add permutation even if none was needed. In some cases, that's a little bit of an optimization concern more than anything else. But yeah, we could just say like when this is going to be the identity permutation, the unsort is just going to say 0, 1, 2 or something like that. Then just don't do it. Like throw that, save the memory, and store a null pointer and just do nothing. Is the same thing. I think most cases will actually do that. This is more of the complex case than the typical case. Star differs in level of indirection. Oh, this is not the same. Okay. There we go. So, let me go get that. So this is how you execute a rule: is you apply the unsort and then you do run the hook. I think what we would do then is after each hook we'll just renormalize. So during the hook you can set whatever you want, but you don't usually execute another parameter. Up here you want to count on it being in normalized order. So maybe I'm just saying normalize first, then grab the pattern. We can eventually digest all of this into one simpler loop here without having to split off quite as many steps. But the state unsort and state normalize might want to stay. At some point I might be able to run these matches without having to actually set aside memory for the pattern. Then you look up and find your rule, and if you've got a rule, you do some work to call it. Whatever happens there, when you come through here, yeah, this seems right. And then normalize there so you don't have to here. After you say go to, you scramble the states again. So they get scrambled once for the call potentially. They might then get scrambled again by the logic of the hook. And then you normalize and look up your rule and go again. Okay. I should probably stop in the next 10 or 15 minutes to get proper lunch. But, I want to see this go. Okay, so what are the steps here? Because that is technically the correct output, but I want to see if it's correct for the right reasons. Now the rule is null. That is what I thought would be different. So let's look at this more carefully. So this is an example actually where because I'm using quicksort and it's not stable, even though it was already in sorted order, it's in sorted order either way, and it chose to go with the change. So there actually is an unsort key, but it's irrelevant. This should be one that I could detect as irrelevant, but I can't yet. I'd probably, what I got to do is just scan the array first, and if it's already in sorted order, then I just say, hey, we're not going to bother, and then we put the null in, right? That'd be the fast way to get out of the problem. Now the pattern should look like, ooh, that's a bit different than I expected. Can I understand why it looks like that? If I had to take a guess, it's probably because the bias didn't get set before. No, that's not it either. Man, that's weird. Okay, so let's go back a step and look at the registry. Something isn't adding up right here. Right, so we're passing in 2, combat round, and combat round. The question is, what do those look like? I see. So they are wrong here. And that would be because this ran before the enums got resolved, and so this doesn't work. So the best ideas I've got. The best idea I've got is I could defer resolution on the ID to main, and then here instead of passing states, I have to pass the raw version of the state ID that is not normalized down to 0, so it'll be the addresses. It means I'll have to use a slightly different macro. And I'll have to implement it differently. It won't be a var u32. It'll have to be a var putter. Hmm. Tricky.
Ultimately, this can be baked away. Once once I'm monkeying with the symbols directly, this won't be a problem.
It's just okay. Um, so what would have to happen is, first of all, this has to become U64. What are you talking about? This wasn't an issue when we were doing this. Oh, well, it is now. Okay, so it's not that. I changed this, but I didn't change rule script. It still has the S1, S0 helper thing going on. You stick the symbol in. So just to be sure, oh, I get it. Okay. Then we'll have to use main to do the fix up. Perfect. Now we normalize, unsort still gets fiddled around. We create a rule, we stick it in. And now, when we go to get a rule, we should be able to find one. But we still don't. That's so strange to me. Okay. Let me just double check a few things. What happens here? Oh. That's wrong. Okay, so it gets a rule. It's going to meaninglessly put the first thing in the second slot and the second thing in the first slot, because that funny thing where unsort has contents even though the array didn't need to be unsorted in this case to be correct. Memory copy array, memory copy array. Pops out the bottom, normalizes the array, which in this case means it meaninglessly swaps them since it's a quick sort again. We figure out the pattern. We find out that there's no rule for that pattern because I only have one rule in the system, so I don't have a fight rule, and that's where the exit happens. Okay. All right. I am going to stop here and get myself a full proper lunch because I can feel myself losing the ability to lock in as I'm sitting here working on it. So I'll be back in another hour, hour and a half, 2 hours, something like that. And my goal for the day when I come back is to hang out and get, not this, this was a new sketch for how the new brain system might work. I want to get more states in the system plugged in. So that starts with fight, which is the most complex one. And maybe I also want to I might actually want to be able to figure out a way to test out the brain scripting for fleeing. No, that's too much. So for today, the last step will be to get this function up and running. I think that's a reasonable goal because that's a lot of stuff. We got to redo the move system. We got to redo. We got to make more progress on this whole thing with players. Still, I want to make progress on that since I haven't actually closed the loop on that thought. And then there's shuffle and run moves and KO checks and all this stuff has to go on. So I think that this will be a good goal for the second part of today. Yeah. Okay, I will be back after having lunch. See ya later.